Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about removing discontinuities. So, one of the discontinuities that we talked about is called a hole, and it's also called a removable discontinuity. And that implies that it's possible to remove the discontinuity somehow. But how do you do that? So, how we remove a discontinuity is we turn f of x into a piecewise function where it equals f of x for all values of x except for a, and then some value b for x equals a. So let's try this problem. Jackie's y position is defined as x squared minus 3x plus 2. Shadow's y position is defined as x cubed minus 2x squared minus x plus 2. Now, we want to find Sunny's y position, which is Jackie's y position divided by Shadow's y position for x is greater than 0. And it tells us that there are 2 points where the limit exists, but the target x value has an undefined y value. Where are those 2 points, and what value should Sunny take on in those 2 points to fly a nice, smooth, continuous path? Like if she's going to fly a path like this that's continuous, what 2 points would we need to fill in with a new value, and what should those values be? So on the calculator here, we have our function, which is Sunny's y position. It's Jackie's divided by Shadow's. So we have this rational function right here. Now to find where this function has a limit that exists but is undefined, we want to find the places where it equals 0 over 0. So we want the zeros of the numerator and the denominator, and that means we're going to need to factor them. So this top right here, that can be factored as x minus 1 times x minus 2. And then for the cubic on the bottom, we can split it up like this and pull out an x squared, and we get this in this form right here. And that is the same as x squared minus 1 times x minus 2. And then we can just do difference of squares on the x squared minus 1. It turns into an x plus 1, x minus 1. And now we have our rational function fully factored. And we have an x minus 1 and an x minus 2 in both the top and the bottom. So that means that x equals 1 and x equals 2. That's where we're going to have our 0 over zeros, and it's going to be undefined. So that's part 1. But the second part, we want to find the values that will plug these holes and will make the function continuous. So we're just going to cancel these out on the top and the bottom because we're taking the limit, so we can cancel these out. You don't have to worry about them. We just have 1 over x plus 1. Now, at x equals 1, it's getting closer to 2 down here, so the limit is 1/2. And then at x equals 2, 2 plus 1 is 3, so it's 1/3. The limit's approaching 1/3. And that's how you solve it. Sunny should have y values of 1/2 and 1/3 in order to maintain continuous flight. Now let's look at another example with a graph. So we have this graph of f of x, and f of x has discontinuities at x equals -2, 1, 2, and 3. And it also has one at 4. So we want to know which of these discontinuities are removable, and what y value could be used to make f of x continuous at those points. The important thing is that not all discontinuities can be removed. If you have a jump or an infinite discontinuity, you can't remove it. It only works for a hole in the graph where you can plug the hole with a point. So if we look at this graph of f of x, right here at -2, we just have this open circle. So we should be able to fill this in. And the first point should be filled in as -2, 4. Now this next point, x equals 1, this is just a single point missing. And the limit as x approaches 1, it's getting closer, y equals 1. So that's 1, 1. Now at 2, the limit from the left, it's approaching 4. The limit from the right, it's 1/2. That's a jump. You can't remove that discontinuity. So let's move on to the next one. X equals 3. It's approaching 1 from both sides. So the limit is 1. So our answer is going to be 3, 1 for that point, which we fill in. And then at 4, it's going up without bound. It's going down without bound. That's an infinite discontinuity. You can't fill that in. So that's our answers. We can remove the discontinuities only at -2, 1, and 3. And we fill them in with the values 4, 1, and 1. So that's it for today, and I'll see you next time.